In this video, we'll learn about the angle between two lines. So let's set things up. We have our x-axis, y-axis, and we have these two lines, blue and yellow, and they're intersecting at this point. Now before we look at the point of intersection, let's look at one of these lines. Let's look at this blue line. It's already making an angle with one other line. And what's that other line? Well, that's our x-axis. And we have defined it like this. The angle made by this line with the positive x-axis in the anti-clockwise direction, that angle defines the slope of this line. If that angle is theta, tan theta is the slope of this line. What about this one? This angle will give us the slope of this line. Now let's talk about the point of intersection. This white angle is the angle between these two lines. Is this angle related to these two blue and yellow angles? Think about it. Well, yes, it is. If you look at it closely, this angle is the difference between these two angles. This is your yellow angle minus this is your blue angle. So yellow minus blue will give you white. And we'll use this and some identities from the trigonometry world to derive the formula for the angle between two lines. Okay, let's do that. This one is alpha 1, this one is alpha 2. So these two angles are given. Now, what's this angle? This is theta, that's alpha 1 minus alpha 2 is the difference between these two. Okay, so slope of this line is m1, that's tan alpha 1, and slope of this line is m2, that's tan alpha 2. Let's try finding the value of this angle in the terms of m1 and m2. Do you want to give this a try? Pause the video. Try this on your own. Okay, let's do this together. We have tan of theta, that's tan of alpha 1 minus alpha 2. And here we can use tan A minus B. So tan A minus B is tan A minus tan B by 1 plus tan A tan B. Now plugging the values of tan alpha 1 and tan alpha 2 as m1 and m2, this is what we get. We'll get m1 minus m2 divided by 1 plus m1 m2. And this is the formula for the angle between the two lines. It's technically the formula for the tan of that angle, but if you know the tan, you can figure out the angle. So tan theta, that's m1 minus m2 by 1 plus m1 m2. Alright, now a couple of observations. Which one's m1 and which one's m2? Depending on which line you pick first, suppose you don't see the screen, suppose you don't see this image, and you're only looking at two equations of two lines. Without plotting those lines, you're trying to figure out the angle between those lines. So depending on which slope you pick first, you'll get a different answer for this. If you switch the order of these slopes, if you pick the second line first, you'll get m2 minus m1. That's going to be the exact opposite of this answer. So either you'll get a positive value or you'll get the same thing but with a negative sign. For example, you might get something like 10 or you might get something like minus 10. So that's the first observation. Depending on which angle we pick first, the value could be positive or negative. And trigonometry helps us figure this out. Tan of minus theta, that's actually equal to minus tan theta. And if you put theta as alpha 1 minus alpha 2, we can see that if you put alpha 2 first, if you're subtracting alpha 2 minus alpha 1, you'll get minus of tan of alpha 1 minus alpha 2. So you can get two answers, one positive and the other one negative. Alright. The next observation is about these values. What do we mean by a positive or a negative value here? Well, tan theta could be positive or negative. The angle could be in the first quadrant or the second quadrant. If the angle theta is in the first quadrant, tan theta will be positive. And if the angle theta is in the second quadrant, tan theta is negative. Tan theta is positive in first and third quadrant and negative in second and fourth. So that's what we're using here. But what is first quadrant? First quadrant is 0 to 90, which means our theta is acute, which means these two lines, and in this case as well, these two lines are making an acute angle. And second quadrant is 90 to 180. This means we are talking about an obtuse angle. So looking at the sign of tan theta, we can figure out whether the angle is acute or obtuse. And these two are related. This one is acute, this one is obtuse. If you look at these lines, they're also making this angle. But these two are supplementary. If you know one, you can get the other, which is why we're mostly concerned about the acute angle between these lines. So we can refine our formula. We can say that if we only want the acute angle between these lines, if you're only concerned about this one, we can say that we're only concerned about the positive value. So tan theta, where theta is the acute angle between these lines, that's mod of m1 minus m2 by 1 plus m1 m2. Now, no matter which slope you pick first, whatever you get, if you take the mod of it, you will always get tan theta, where theta is the acute angle. Now let's solve a problem. If the angle between two lines is pi by 4 and the slope of one of the lines is half, find the slope of the other line. Pause the video, try visualizing what's happening. Okay, let's plot things. We have our x-axis, y-axis, and we draw a line which has a slope half. So this blue line looks like a line that has slope half. Now notice that the question says the angle between lines is pi by 4, which is 45 degrees. Now the line could go in this direction, this angle is 45, or it could go in this direction, this angle is also 45. This yellow line is making an angle of 45 with blue, and this green is also making the angle 45 with blue. Both of them are making 45 degrees, which means we'll get not one, but two such slopes. Alright, we'll find both of them. But before that, here's a quick fun observation. In this specific case where the angle is 45, both of them add up to 90, which means whatever we get here, we're talking about perpendicular lines. The two lines, the two slopes that we're after, both of them are of lines which are perpendicular to each other. Okay, let's get started. Let's assume that the slope that we're trying to figure out is m. So this other line could have two different slopes. It could be higher than half or it could be lower than half. So this means this variable m will give us two values. So let's plug our value of m in this formula. Tan theta, where theta is the acute angle between these two, is mod of m1 minus m2 by 1 plus m1 m2. Okay, here we know one of these slopes, that's half, and we need to figure out the other slope, that's m. So tan theta, this theta is pi by 4. Let's say the m1 is m minus half by 1 plus m times half, so that's m by 2. Tan pi by 4 is 1, which means this value, here we can take 2 as LCM and cancel it out. This is 2m minus 1 and this is 2 plus m. So on the right hand side we have mod of 2m minus 1 by 2 plus m, and on the left hand side we have 1. And now we need to solve this equation. Because we have a mod, we'll probably get two values of m. Let's see them. So 2m minus 1 by 2 plus m, what's inside the mod could be 1 or minus 1. Both these values give the mod as 1. So here we get two equations. This is how we break down the mod. So the first equation is 2m minus 1 by 2 plus m is equal to 1. And the second one is that's equal to minus 1. Now if you take the denominator to the other side, you'll get 2m minus 1 equals to 1 times 2 plus m. That's 2 plus m. Or the other one where 2m minus 1 is equal to minus 1 times 2 plus m. So this gives minus 2 minus m. Let's solve both of them. Here we have 2m and m. So m cancels. We have m equals to 2 plus 1, 3. So m is equal to 3. And here we have 2m plus m. That's 3m. And this side is minus 2m plus 1. That's minus 1. So 3m equals to minus 1, which means m equals to minus 1 by 3. So m equals to 3 or m equals to minus 1 by 3. This means this line has a slope of 3 and this line, this green one, has a slope of minus 1 by 3. And 45 plus 45 is 90, which is exactly what we're getting. These two slopes multiplied give us minus 1. If two slopes multiplied give minus 1, this means they're from perpendicular lines. So we're getting two such slopes here and they are in fact perpendicular.